How are electrons arranged? Part 2. In this video, we will know how to arrange electrons in shells. This refers to the shell and this refers to electron. This is the first shell, this is the second shell, and this is the third shell. This is the periodic table. Here we will know how to arrange electrons according to atomic number. We arrange elements in periodic tables according to atomic number in increasing order, from 1 to 20. The column refers to the group. We have from 1 to 8 group. This is group number 1. Column refers to the group. This is group number 1. This is group number 2. This is group number 3. This is group number 4. And this is group number 5. This is group number 6. This is group number 7. And this is group number 8. Period. The row refers to the period. This is period number 1, period number 2, period number 3, period number 4. Here, this is one shell. Here, these are 2 shells. These are 3 shells. These are 4 shells. According to the number of the shell, we have the period number. This is 1 shell, period number 1. 2 shells, period number 2. 3 shells, period number 3. 4 shells, period number 4. According to the valency electrons, the electrons present in the outer shell, it refers to the number of group. For example, hydrogen atom. We have atomic number equal 1, equal to the proton number, equal to the number of electrons. So we make distribution of 1 electrons. So hydrogen atom present in the outer shell 1 electron, so present in group 1. And also have 1 shell, so present in period number 1. Another example, helium atom. Atomic number 2. We make distribution of 2 electrons because atomic number 2 equal to the number of electrons. We have 2 electrons in the outer shell. Next. Lithium atom. Atomic number equal 3. So equal to proton number equal to the electron number. So we make distribution to 3 electrons. The first shell fell with 2 electrons according to the rule, and the second shell, the remaining electrons equal 1. So we have 2 plus 1. 1 electron in the outer shell called valency electron, so present in group number 1. And we have 2 shells, so present in period number 2. Next, beryllium atom. Atomic number 4. We make distribution for 4 electrons. The first shell filled with 2 electrons, and the second shell filled with 2 electrons, 2 plus 2. Here the outer shell has 2 electrons, so beryllium present in group 2. This is the valency electrons. And we have 2 shells, so beryllium present in period number 2. Boron, atomic number 5. equal to the number of electrons, so we make distribution of 5 electrons in the first shell filled with 2 electrons according to the rule, and in the second shell we have the remaining of electrons, 3 electrons, so 2 plus 3. 3 here is the valency electrons, number of electrons in the outer shell, so we represent the group number 3. Boron present in group number 3, and according to the shell, 2 shells, period number 2. Boron present in period number 2. Next, carbon atom, atomic number 6. We have 6 electrons. We make distribution of 6 electrons in the first shell filled with 2 electrons according to the rule, and in the second shell the remaining of electrons, 4 electrons, so 2 plus 4. These 4 called valency electrons that is present in the outer shell. So carbon present in group 4, this column, and according to the shell, 1, 2 shells, so carbon present in period number 2. Next, nitrogen atom, atomic number 7, equal to the number of electrons, and so we make distribution of 7 electrons in the first shell filled with 2 electrons according to the rule, and in the second shell we fill with 5 electrons, 2 plus 5. These 5 electrons indicate that present in group 5, and according to the shell, nitrogen atom present in period number 2. Next, oxygen atom, atomic number 8. We make distribution to 8 electrons because atomic number equal to the number of electrons. So, in the first shell, filled with 2 electrons according to the rule, and in the second shell, filled with 6 electrons, which called valency electron, and according to the electrons present in the outer shell, we know the number of the group number 6. And according to the shell, 2 shells, so oxygen present in period number 2. Next, fluorine atom, atomic number equal 9. So we make distribution of 9 electrons in the first shell filled with 2 electrons, in the second shell filled with 7 electrons. So the distribution of electrons 2 plus 7 according to the valency electrons, the number of electrons present in the outer shell 7, so we represented the group number 7, and period according to the shells, 2 shells, so fluorine atom present in period number 2. Neon atom, atomic number 10, so we make distribution of 10 electrons in the first shell filled with 2 electrons, in the second shell filled with 8 electrons. So neon distribution of electrons 2 plus 8. These 8 electrons represent the group, this valency electrons that is present in the outer shell. So present in group number 8. And we have 2 shells, so neon present in period number 2. Sodium atom, atomic number 11. So we make distribution of 11 electrons according to the rule, in the first shell filled with 2 electrons, in the second shell filled with 8 electrons, and in the third shell the remaining 1 electron. So sodium distribution of electron 2 plus 8 plus 1. 1 is the valency electron, electrons that is present in the outer shell, 1 electron, so present in group number 1. We have 3 shells, 1, 2, 3, 3 shells, so sodium present in period number 3. Next, magnesium atom, atomic number 12, equal to the number of electrons, so we make distribution of 12 electrons in the first shell filled with 2 electrons. In the second shell filled with 8 electrons according to the rule. In the third shell the remaining of electrons 2 electrons. 2 plus 8 plus 2. 2 is the electrons present in the outer shell, which is called the valency electrons. So magnesium present in group 2. And we have 3 shells, so magnesium present in period 3. Next, aluminum or aluminum atom, atomic number 13. Equal to the number of electrons, we make distribution of 13 electrons. In the first shell, filled with 2 electrons. The second shell filled with 8 electrons. And in the third shell, filled with 3 electrons. The distribution of electrons, 2 plus 8 plus 3, according to the number of electrons in the outer shell, 3 electrons, the number of the group, group number 3. And according to the shells, the number of the period, 1, 2, 3, 3, period number 3. Silicon atom, atomic number is 14. So the distribution of electrons equal to 14 electrons. In the first shell, filled with 2 electrons. In the second shell, filled with 8 electrons according to the rule. And in the third shell, the remaining 4 electrons. So silicon distribution of electrons 2 plus 8 plus 4. According to the outer shell, which has 4 electrons, so silicon present in group 4. According to the shells, 1, 2, 3, 3 shells, so silicon present in period number 3. Next, phosphorus atom, 15 atomic number, equal to the number of electrons, so we make distribution of 15 electrons. In the first shell, filled with 2 electrons, according to the rule, and the second shell filled with 8 electrons. The remaining in the third shell, 5 electrons. The distribution of electron 2 plus 8 plus 5. There is 5 electrons in the outer shell. These 5 electrons indicate to the number of group phosphorus present in group number 5. And we have 3 shells, so phosphorus present in period number 3. Next, 16 atomic number, sulfur atom. Sulfur atom, we make distribution of 16 electrons. The first shell filled with 2 electrons, the second shell filled with 8 electrons, and the remaining in the third shell, 6 electrons. The distribution of electrons 8, 2 plus 8 plus 6. In the outer shell, 6 electrons, which is called valency electrons. These 6 electrons indicate to the group number. This is 6 electrons, so group number 6. And we have 3 shells, so indicate to period number 3. Chlorine atom, which has atomic number 17. So we make distribution of 17 electrons in the first shell filled with 2 electrons, in the second shell filled with 8 electrons, in the third shell filled with the remaining 7 electrons. The distribution of electrons 2 plus 6 plus 7. In the outer shell we have 7 electrons, which is called valency electrons. According to these 7 electrons, we know the number of group. Group number 7, chlorine atom present in group number 7. And we have 3 shells, so chlorine atom present in period number 3. Next, argon atom, atomic number 18. We make distribution of 18 electrons because atomic number equal to the number of electrons present in the atom. Argon atom in the first shell filled with 2 electrons, in the second shell filled with 8 electrons, and in the third shell filled with 8 electrons. The distribution of electrons 2 plus 8 plus 8. We have 8 electrons which called valency electrons. In the outer shell we have 8 electrons, so the number of group equal 8. So argon present in group number 8, and also period according to the shell 1, 2, 3, 3 shells according to the shells. Argon atom present in period number 3. Next, potassium atom, atomic number equal to 19. We make distribution of 19 electrons, which is equal to the number of electrons. In the first shell, we fill with 2 electrons. In the second shell, we fill with 8 electrons. In the third shell, we filled with 8 electrons. In the fourth shell, we filled with 1 electron. The distribution of potassium atom 2 plus 8 plus 8 plus 1. According to the rule, the first shell filled with 2 electrons, and the second shell filled with 8 electrons, and the third shell filled with 8 electrons. The outer shell, which is called valency electron, equal 1. So the number of group equal 1. And we have 1, 2, 3, 4, 4 shells. So the period number equal 4. Next, calcium atom. Calcium atom, the atomic number equal 20. So we make distribution of 20 electrons because it equal to the number of electrons. The first shell, according to the rule, filled with 2 electrons, and the second shell filled with 8 electrons. The third shell filled with 8 electrons according to the rule, and the remaining present in the fourth shell, which is 2 electrons. These 2 electrons called valency electron, that is present in the outer shell. So calcium present in group number 2, and according to the shell 1, 2, 3, 4, 4 shells, the period number equal 4 because the shells refers to the period number, and the electrons in the outer shell, which is called the valency electrons, refers to the group. This is group number 2. Calcium present in group number 2 and in period number 4. 2 plus 8 plus 8 plus 2. This is 20, called proton number, and this is equal, and this is called electron shells, and this is the electron distribution.